Yeah, so today we're looking at association rule mining, and basically, I want to reiterate what I said last time that we, as we were beginning this class, I said that our focus majorly is going to be on concepts. So thinking about the concept, what is a concept, and helping ourselves to understand the concept. Okay, understand the concepts. And once you understand the concept, then we will think about how has the concept been applied? How has it been applied in real world? Yeah, in real world. And then from there, we will ask ourselves, how can we apply? So, so for association rule mining, I have thought of just introducing this from the basic level. And by basic level, I am saying just trying to paint a picture of where are we beginning from, where are we starting from, and now building those concepts all the way up and thinking this is where we started, and then this is how it has been built, and now looking at the real life situation we are in right now. How is this being applied right now, and how can we apply it in our day-to-day affairs or wherever we are working? How can we be able to apply the same? And so, in this class, we're going to be looking at Apriori Algorithm, which is an algorithm that, in one way or the other, okay, in itself, it actually applies association rule mining. This algorithm applies association rule mining, and it's basically one among the two that you're going to look at to explain the concept of association rule mining. Because if we were to explain that, then we need to think about the concept from an application level. And so I'm narrowing this down back to where did we all begin. And it's interesting to see that this is a concept that has been there for quite a long time. Yes, the algorithm we are looking at was invented all the way back in 1994. That's quite a number of years right there. And it has been existing. And even the new models that we'll be looking at are actually based on the previous concepts that were developed long time ago, like the algorithm that we're talking about. And so, so this is just think about this from the concept of what we talked about, that you can be able to, if you think about a shopping mall, if you think about a shopping mall, or even an outlet, a supermarket or something, you know that it's possible for you to mine data from the transaction or database of a point of sale, and be able to use that data for making informed decisions on how do you market your products, how do you place your products in various shelves within the supermarket or within the shopping mall, and use that for the purposes of course, just trying to get the customers on board. And so that's very important for us to think about. And this concept that we are learning today is actually a concept that can be applied in there, in just how can we do what we call the market basket analysis. Market basket analysis. So how can we analyze and know the preferences of a customer within a shopping mall, for example? Yeah. And so quite a lot of application of Apriori algorithm is basically around e-commerce applications. Also, it can be applied around recommender systems, and that's a concept that we'll be talking about. But also, like I have said, we will also be applying this in market basket analysis, and seeing how can we be able to apply the algorithm in determining how the behavior of a customer is as far as different products are concerned. Now, let me begin by saying I gave a case in point when we were beginning this class, and I said I was talking about a shop attendant who was working for a company called Walmart in the US. This company. And this guy was interested to get to know how do people, what is the behavior, what is the customer behavior, the buying behavior of a customer. And so he engaged in a research and basically was trying to understand what are the items that a customer frequently buy together. That if a customer buys this item, what is the probability that they're going to buy that item combined with another one? And so he engaged this, and I think this is a case I gave when we were beginning, so you might be familiar with it. And so he engaged in okay, Victor, are you hearing? Let me confirm if others are hearing me so that it's not Victor alone. Prop is getting me clearly. So Victor, you may need to check. Yes, others are hearing me. Victor, you may need to check your connection on that end. Yes. So what I was saying is this guy just decided I want to do a research and get to understand what is the probability that if a customer buys a particular product, they will buy that product combined with another one. And that's what he did. He started that research. And so he looked at those customers that were buying diapers, diapers for the kids. And he was interested to know what is the other item that this customer buys with diapers so frequently. And he did his research, and amazingly, when he checked the transactional database, he realized that any customer who was buying diapers, there was a high probability, very high probability, that they would buy a bottle of wine. And that was like, oh no, I would expect diaper with some petroleum jelly or diaper with some tissue, stuff like that. But this is just awkward, And so he did further, investigation to get to know what does that mean. And he just realized the parents in the US are very, very stressed up by parenting responsibilities, and so they needed a way to keep going. And just the depression was too high, because they are career people at the same time they are parenting, at the same time they are combining maybe 2 jobs or something to make a living, and that was quite stressful. And so from that time, then it was very clear that it's not just it's not obvious that a customer will buy this product and buy that product with another one, as we may know it. But it was very clear that there is a probability that a customer will buy a product, and once they buy that product, buy that product with another one that we may not even have thought about right there. And so the concept that we are learning today is basically to be able to help us to understand what is the probability. Just looking at probabilities, that if this particular item is bought, what is the probability that another item is going to be bought together in a shopping mall? And just computing, getting to know what we'll call the confidence level, the lift around that, and computing those, making those computations happen. And so association rule mining, in our lectures here, we'll be looking at these two algorithms for generating frequent item sets within a transactional database. So in our case here, there is more of the data that we are thinking about is a real life data. It's a live data within a transactional database, not data within a data warehouse. It's within a transactional data. Transactional warehouse, a transactional database, not a warehouse. And so we'll start with association. We start with a Brittle algorithm, and then we'll go to frequent pattern growth algorithm. So think about item sets, and we'll talk about this a lot. When you hear of item sets, think about item sets from the perspective of you go to a shopping mall and you pick some 2 pens, an exercise book, a marker, or those items that you come to a cashier or whoever is a shop attendant, those items that you come with for them to serve you. Those are the things that we are calling item sets in this case. And so we will be looking at a case in point whereby each and every customer is referred using a customer ID. And within a particular customer ID, there are item sets. And so when you go to a shopping mall, unless you use your, what do we call these cards? Royalty cards, yeah? Unless you use your royalty cards to buy, many people Jacob, unaingia na fujo sana. Unless you use royalty cards to buy, then you can be sure that the person at the counter may actually not know your name. They may not know your name unless you use a credit card to pay, or you use your royalty card to get some cards. So the point here is that within the transactional database, you are known using a transactional ID and not using your name, most probably, yeah? And so we'll be looking at item sets within that are referred using a particular transactional ID. Item sets that are referred using a particular transactional ID. And we'll be looking at that quite a lot. But also we'll be trying to generate the frequency that a particular item is appearing in different transactional IDs. So that would mean, Ochieng has come to a shopping mall, Kipkoskei has come, Brian has come, Winnie has come, and all of us have come to a shopping mall. We have shopped, we have been, we have paid, and the transactional database is referring to us using a particular transactional ID. And so the probability that a pen is available in all these transactional IDs, that all the customers that came, they were able to buy, or all of them bought a pen. So we'll be looking at some of those. So generating the frequent item sets within the transaction, within a particular data set that we are dealing with will be of essence to us here. So the other thing that I need to mention, so here, what you need to note from the slide that I'm providing right now is that the process is very simple for the Apriori algorithm. It's basically get a data set which you have generated from a transactional ID, a transactional database. From that data set, generate the item sets and generate the item sets together with their support. So support is basically how many times is that particular item how many times is the item appearing in all the transactional IDs that we are talking about. And so you will set a support, and we'll do an example. You set a minimum support count for a particular a particular data set that you are dealing with. Say that for item that has a support lower than 3, then it means that item is not frequent, because we just want to deal with the frequent item sets. And so we'll check the support, and once we check if the item has a support lower than the set support, then we can prune. Otherwise, we can continue to generate frequent item sets. I'll get back to this in a short while, so that we can get to understand better. Now, in this, like I said, yes, there is a bit of computation, so you may want to, yes, I can see Diambo, you're saying you're not getting, but I will, I hope what you mean is that you are not understanding what I'm saying, because I am just introducing. So once when I get to a place when I think I have already explained everything I need to explain, and you say you're not getting, that's when I can repeat. But right now, I'm just introducing the concept. Okay, so so what I'm saying is, you may have done some maths around data sets. Even here in ZTech, I expect probably you may have done a course on sets. And so those are some of the things that we may be recording even in this class, just trying to understand. So let me get back into it. I was just giving a scenario, but let me get back into it. And I'm saying the support is one key item that, one key terminology that we'll be using here, support. And support is basically, it's just the probability, let me say, the probability. And it's basically that if you have items, 10 items, what is the probability that a particular item, or rather, let me say, if we have 10 customers who have shopped in our shopping mall, what is the probability that out of those 10 customers, that a pen will be bought by those 10 customers? That is what support would mean, okay? What is the probability that a pen is going to be bought by 10 customers who have come into our shopping mall? And so as we compute support, then we'll be looking at what is the number of transactions in which a particular item X appears, okay? And what is the total transactions that were done by a given, within a given period. So let's say by the end of the day, we want to check how many people bought a packet of milk. Yeah, how many people bought a packet of milk? And we are comparing that with what were the total number of transactions that were done in that particular day. And that is what would give us the support count. The support of a given item, remember, it's the support of a given item. I'm thinking of an idea of trying to enlarge my slide. I think it's not very clear. So here what we are saying is, get the support of, we'll be computing the support of a given item, of a given data set, just to try and understand the probability that if a particular item, the probability of a particular item being bought in an array of transactions that have been done within the transactional database. So that's one. And the other one is, I don't know if I had brought it here, but let me check. Yes, confidence. And confidence here is the likelihood. It signifies the likelihood that an item Y is being purchased when another item X is being purchased. And that would be very important, because you want to compare and see what is the probability that if someone buys a bottle of juice what is the probability that they will buy some peanut butter together? Because the moment you understand the customer's behavior, it becomes very easy for you to determine, then how do we move on from here? Yeah, it becomes very easy for you to determine how do we move on from here. You can actually determine even how do you arrange the items within the shopping mall based on the customer behavior. And that would be a more proactive way to organize your data, or rather to organize your items, as opposed to saying, let me put them the way every other person or every other shopping mall does. It would be more proactive to say that I'm putting this item here and this other item here, because I am sure that if I put them that way, they will sell each other. That if I put, a bottle of, or rather juice together with Coke, I know they will sell each other, because probably in one way or the other, yeah, someone will consider, or because those items are bought together. But also, it's very interesting that those items that, for example, when you look at many shopping malls, and this is something I mentioned earlier, when you look at some many shopping malls, you realize that tea leaves are not placed together with milk. Yeah. And mostly it's because, from the statistics, it has been proven that when you are buying milk and you are buying tea leaves, mostly it is usually not impulse buying. It's something that you had made a decision you want to do. But when you're buying peanut butter, or not peanut butter, for some of us, probably we prefer those items. But there are some items that you buy not because you had planned for it, but because you have just seen it in the shopping mall and you realize, oh, probably I can buy this toy, or I can buy this item. So out of just impulse buying, but it's not because that you had planned for it. And so even how we organize items, we may organize them in a way that we want to probe the customer to move around looking for a particular item. So you've gotten a packet of milk, you want to buy sugar, you don't know where it is. So you start walking around. And as you're walking around, you'll bump into something that you had not planned to buy, and you'll actually consider to buy it. Yeah. And out of that, more income, comes to the market, or to that particular business. And so the other thing that we may be interested in is actually what we call lift. And lift is basically, what is the probability that an item X is going to be bought together with an item Y, considering the popularity of an item X. Okay. So, and that would mean, for example, what is the probability that I will buy orange juice together with Coke based on the popularity of Coke, for example? Yeah. So, and that is also very important for any given shopping malls. And maybe if we were to move this from a conceptual point of view, which we have said, then you would realize that another place for us to, the other way to think about this is now to think, if this is a model, what is the system that can actually predict the buying behavior of a customer? Because if you come with such a system and it's able to predict with certainty the buying behavior of a customer, you can be sure that many shopping malls would consider, if a system is actually helping you to generate more revenue, why not consider? Yeah. And so those are areas that we may want now to take this from conceptual point of view and bring it into a place of application. And to be honest, that's an area that I would want you as a student to explore. So basically what I'm saying is, lift is the probability that I'll buy an item with another item considering the popularity of the first item. That is what we mean by lift. And so there are many, of course, each and every idea, or each and every invention has its own advantages and disadvantages. And so there are many pros and cons around Apriori algorithm. But I must say, this in one way or the other helps me to understand, but also to explain the concept of associating items, or associating item sets within a data set. It helps me to explain this quite easily, because you can actually see it even from a real life situation. You can understand what I'm talking about. And so you'll be able to check some of those pros and cons of this algorithm. Yes, but also, of course, this lecture will be available in our lecture, in this course dashboard, for your review as well. So yes, there are ways that we can be able to improve the efficiency, especially because we are saying some of the cons of this algorithm is that sometimes it may need to find you may need to find large number of candidate rules, which can be computationally very expensive. If you think of, you are dealing with millions of transactions within a database within a given day, and you go through the process that we are just about to go through, then you realize it's very expensive. It's an expensive affair in terms of time, in terms of resources, in terms of even accuracy. It's quite expensive. And so there are ways, for example, transaction reduction, trying to narrow down, to the frequent item sets that are there. So the transaction not containing any frequent item sets, you remove them, yeah? You scan and you remove them. And that helps you to remain with the most relevant data set from a given transaction or database. Yeah, so there are various ways that we can be able to improve the efficiency of this. But allow me to just look at a case in point. Now, it's very unfortunate that I would have really wished that, I don't know if I should try this from a different platform. But yes, I would have really wished that we use. I would have wished that we use. I do my computation from the screen, but I think the machine I'm using cannot allow me to do that, because the best way to do that is actually using a touch screen, which it's not what I'm using at the moment. But I want to take this example, and what I would want to encourage us is try and copy this example on your exercise book, and then we can go together. We can move together. So the question is, consider the following data sets, and we'll find the frequent item sets and generate association rules from them. So what this means is, and this is where I'll be asking us to answer some questions, especially from what we have just discussed. So one, we have all through, and every single time we will be using, we'll have a particular support count, minimum support count that we have set, okay? Minimum support count that we have set. And so if we were to do computation any given time, there will be the minimum support count that we are using for that data set, which, depending on any given, depending on the accuracy, for example, that you want to consider, depending on the number of transactions you want to have, or rather that you have in that given transaction, all those considerations can help you to set the minimum support count. So in our transaction, so let's say this is a data set that we have Okay. Somebody is saying that some of the values are not very visible. Let me try and see what I can do. Thank you for that concern. I don't know if this will help. I don't know if this will help. Let me know if this helps. Is it more visible now? Is it visible? Okay. So basically what we are saying is that we have, okay, let me hear from us. How many customers are in this transaction or in this data set? How many customers? How many customers? Let me hear from someone. If you are to consider this as a data set that is coming from a given transaction or database, then we would say how many customers do we have? I'm seeing some of us typing, so let me wait and see. 9 customers, Nelson, thank you. So in this case, it's 9 customers. Then each customer bought particular items. And those items, in fact, you can even just write them as 1, 2, 3, 2, 4, 2, 3, 1, 2, 4, 1, 3, 2, 3. You can write them as that because it's I1, I2, I3, I4, I5. So let me ask, in total, how many particular items, were bought? Okay, not in total, but I'm saying how many distinct items were bought from these shopping malls? How many distinct items were bought from this shopping mall? 5 items, correct. I think we are following now. So we have 5 items that have been bought from this shopping mall, but each and every customer is buying their own items. So we are saying customer 1 bought item 1, 2, and 5. Customer 2, Joyce, you can mute yourself. Customer 2 bought item 2 and 4. Customer 3 bought item 2 and 3, all that. So each ID is representing a customer. And each customer bought particular items that are within the data, the larger data set that we are looking at here. And so that helps you to understand what we are looking at when we talk about, when you talk about, item sets within data set that is found within a transactional database. So if I say, if I say a customer with transaction ID 1 has an item set, or has item set 1, 2, okay, has item set that has 3 items within that item set, then you'll be able to understand what I mean. That a particular customer has this number of items, and the collection of items is what we are calling the item sets. In short, the collection of those items is what we are calling item sets. And so each and every customer is able to buy particular items, and so we'll compute what is the frequency of a given item in all the transactions that were made. What is the probability that this item was bought? What is the probability that this item was bought? What is the probability that this item was bought? Then we'll go further and compute what is the probability that this item and this item were bought together. And that's how we are gonna go about it. So if you've copied this, now look at the support. Look at the support. The minimum support count is 2, and the minimum confidence level is 60%. So that is to mean that we will only say that we have frequent item sets if they get to the threshold. And the threshold here is a minimum confidence level of 60%. I know some of us here are in research, and you know what we mean by the confidence level. Most of the time, actually, we usually say plus or minus 10. So 90% confidence level or 110 confidence level when you are looking at research. And basically it's because we want to be able to get the highest level of accuracy as far as, you know, our data is concerned, the highest level of accuracy. So let me get into maybe just explaining. So the first step here is generate. So let me get you back here. And I want you to come up with the list of, I know you've copied this. So come up with a list of, item 1, 2, 3, 4, and 5. And tell me what is the support of each and every item. That is to mean how many times item 1 appears in all the transactions that were done. How many times item 2 appears in all the transactions that were done. And how many times item 3, 4, and 5, each one of them, how many times it appears in all the transactions that were done. So quick answers there. Quick answers, sorry, I think let me just try to share this again. So if we say transaction ID 1, okay, let's not transaction ID, but item 1, 2, 3, 4, 5. If we say item 1, how many times does item 1 appear in our data set? How many times does item 1 appear in our data set? Item 1, 6, correct. Item 2? Item 2? Item 2, 7, correct. Kipkoech, Omondi and Kipsang, Kipkoske. Oh, okay. The Kips here are shining. Okay. Just go ahead. Okay. Item 3, 6, correct. Item 4? Item 4, 2. Item 5? Item 5? Item 5, 2, correct. Okay. So you are just trying to look at the frequency of each and every item. And so this is the table that you'll come up with, such a table as this. Okay. So a table that shows the support of a given item. And support here, support count means the number of times a given item is appearing within the data set that we are looking at, which we have derived from a transactional database. Okay, so the number of times that a given item appears within the transaction, within the data set that we are using, is what we are calling the support count. And so support count for 1 is 6, for 2 is 7, for 3 is 6, for 4 is 2, and for 5 is 2. Okay, then we look at, we will compare this with our minimum support. Okay, so we'll compare this with our minimum support. So if you think about it, our minimum support is 2. And so what we are saying here is, if a given item has a support that is lower than the minimum support, we do something we call pruning. If a given item has a support that is higher than the minimum support count, we join. Okay, we do joining. So let me repeat that we are looking at the support of each and every item that is available in the data set we are using. And we are asking ourselves this one question: what is the support count of a given item? Is that support count lower, greater or less than the minimum support count that we have set? And so if the item has a support count that is higher than the minimum support count, we are going to do joining. But if a given item has a support that is lower than the minimum support count, we are going to do pruning. And pruning here means we eliminate. We will disregard those items with a support that is lower than the minimum support count. Okay? We'll disregard those items that have a support count that is lower than the minimum support count. And so if you look at our data set, you realize that all items are actually frequent. And by saying frequent, what I mean is they have a support that is higher or equal to the minimum support count. And so there is nothing to prune. There is nothing to prune. If you look at it, there is nothing to prune. So the only thing we can do is we do iteration again. So another iteration by joining the items. Joining the items. So what am I asking? I'm asking what are the combinations that we can have? We can have item 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5. Okay. Then 2 and 3, 2 and 4, 2 and 5. So we'll just do that combination. And let me show you the results that you get. So you get something like this. Something like this. So here what we have is we have done what we call joining. And joining, what it means here is we are taking two items, join them together, and we look at the support count of those two items. And the support here is how many times those two items were bought together from all the transactional IDs that we have. Okay. So if you check from the initial table that you created, you'll see that item 1 and 2 were bought together in transaction ID 1, transaction ID 4, transaction ID 8, and transaction ID 9. And so the support count for item 1 and 2 combined together is 4. The support count for item 1 and 2 combined together is 4. The support count of item 1 and 3 combined together is also 4 because it was bought in transaction ID. Let me check. 5. Which other one? Transaction ID. Which other one? So the support, we are saying the support of 1 combined with 3 is 4 because it was bought together in transaction ID 5 and 7, correct? And which other one? 8 and 9, correct? Okay, I see you are following. So the 4 is now becomes the support of, rather, like how many times these two items were bought together, yeah, by different customers. And so once we generate that, we go back and ask ourselves again the question. And the big question here is, how many item sets have a support higher than the minimum support count? How many have a support lower than the minimum support count? So if an item set has a support higher than the minimum support count, then we will join. If it has a support lower than the minimum support count, we will prune. And the pruning here is just eliminating. We will deem those particular transactions as transactions that are not frequent, because we want to deal with the frequent items. The frequent items that are bought together severally, as many as possible. Because the higher the chances of items being bought together, then that is also escalating in a way the chances that if we put those items together, they will be selling each other. So in this case, which ones do we prune? Which ones do we join? So we can say item 1 and 2, we will retain. We will retain item 1 and 3. We will retain item 1 and 5. We will retain item 2 and 3. We will retain item 2 and 4, 2 and 5. Yeah, just that. Okay. We retain those item sets. Those item sets. And so once we retain, then what do? We iterate again. We iterate again. So I want someone, maybe for someone to do some computations there and tell me what are you getting? Okay. Let me repeat. So what I'm saying is we did the first iteration. And in the first iteration, we realized that we had 5 items within our data set. Item 1, 2, 3, 4, and 5. And we were trying to get the support count of all those items. And so for item 1, 2, 3, 4, and 5, item 1, we got the support is 6, item 2, 7, item 3, 6, item 4, 2, and item 5, the support was 2 also. And so at this level, we asked ourselves, is there an item or okay, is there an item, because it's item in this case, they are not items, it's just an item. Is there an item that has a support count lower than the minimum support count? And we realize there is no item. Okay, in this case is lower or equal to. Is there an item that has a support lower or equal to the minimum support count? And we realize there isn't. And so there is nothing to prune. So the only thing we do is we join. So we pick items and join them together. And the possibilities that we can have are the ones I have on the screen right now. The possibilities of these items joined together, the number of times that we can have, or all the possibilities are on the screen right now. 1 and 2, 1 and 3, 1 and 4, 1 and 5, then 2 and 3, 2 and 4, 2 and 5, then 3 and 4, and 3 and 5. Those are the only possibilities. So once we have this, then we'll be looking at 1 and 2 and checking the data set that we had from the transactional database. And the data set where we are asking ourselves, from the 9 transactional IDs, how many times it was 1 and 2 bought together? How many times was 1 and 2 bought together? So if, and when I look at that, I'll see that in transaction ID 1, we have 1, 2, and 5. So 1 and 2 are bought together. I will move down and see in transaction ID 4, 1 and 2 were bought together because this person bought item 1, 2, and 4. And so 1 and 2 are there. I'll go down again in transaction 8 and transaction 9. 1 and 2 are bought together. And so I will get to know the support count of 1 and 2. And the support count here is 4. I'll go down to 1 and 3. The support count is 4 because 1 and 3 was bought together in transaction ID 5, 7, 8, and 9. If I go to transaction, if I go to item set 1 and 4, and ask myself what is the support, I am seeing it's 1, because items 1 and 4 are bought together only once, and that is in, where is that? In transaction ID 4, if you check that, yeah, only in transaction ID 4. And I can try to go back to here. Only in transaction ID 4 is where, those items 1 and 4 are bought together. And so I generate the new support for all the item sets. And then all the item sets that have a support count lower than the minimum support count. Remember, the minimum support count is set by default. So all the items that have a support lower than the minimum support count, we prune them, we eliminate them, we disregard them. But those items that have a support equal or greater than the minimum support count, we retain them and then we join them again. We retain them and then we join them again. So this is what I get. So after I do the pruning, this is how my table looks like. These are the frequent items so far. Are we in agreement? Let me hear if we are clear. Stacy, are we clear? You are saying I pardon what I was saying. Okay. So this is the table that I get once I have done pruning. And so you realize that all the item sets that are there in this table are frequent. So once I do this, the next point is to iterate again. So that is to mean each item set will have 3 items. Each item set will have 3 items. So in this case, in this table, each item set has just two items. But in the next iteration, each item set will have 3 items. So what are the possible combinations there? What are the possible combinations? Of course, 1, 2, and 3 is the one that starts. 2, 3, and 4. Okay. So just get me the possible combinations and the support. Possible combinations and the support. Let me hear the possible combinations and the support. Naftali, are you there? Naftali. Possible combinations and the support. Let me see how many people. So, how many people are here? Okay, I believe most of us, from my assessment, most of us are following what we are saying. So get me the possible combinations with 3 items in each combination, in each item set, if I may say. 3 items in each item set, and you give me, so like for example, Kipsang is saying 3, 4, and 5. That's one of the combinations that we can have. So that's what I want. And then you'll get me what is the support. For example, 1, 2, and 3 with a support of 2. I think that's correct. 1, 2, and 3 with the support of 2. That's correct, yes. So that's what I'm looking for. Any other possible combination? Okay, I want all the combinations. Before I do the pruning, I must have all the combinations with their support. So we have 1, 2, and 3 with a support count of 2, which is correct. Which is the other combination? One, 2, and 5 1, 2, and 5 with the support of 2. Yes, that's correct. Yes, now I see we are getting what I'm saying here. Good. So, like for example, Kipsang is saying 3, 4, and 5, the support is 0. So that candidate should be pruned because the support is lower or less, or it's less than, the support is less than the minimum support. Okay, Jacob, let me see how you got that. 2, 3, and 5 support of 8. I doubt if that is right. 2, 3, and 5. 2, 3, and 5. 2, 3, and 5. What is the support? Somebody help us. What is the support of 2, 3, and 5? Because yes, I agree with you, Jacob, that 2, 3, and 5 is actually, a possible combination here. But the support is actually 1. Yes, like Brian, Michelle. Oh, Michelle is here. Okay. Michelle, Kipsang, and Joroge, Eva, and Stacy, and all those people, what they are saying is true. That the only support that we have for combination 1, what was it? The combination was 1, 2, 3, and 5. 2, 3, and 5. 2, 3, and 5. 2, 3, and 5 is only in transaction ID 8 only. If you check in our transactional database, and I'm saying this also to know if it's making sense to you, Jacob, because of course it's okay. It's good for you to confirm that, because I would want also for you to understand what we are talking about. Okay, so we are there. So just a quick one, a quick question is, which are the candidate sets that we can do joining? Which are the candidate sets, which are the candidate sets that qualify for joining? Because those are the only ones that we need to move to the next level. I'm not asking of how many, I'm asking of which ones. So you tell me 1, 2, and 3, 4, 5, 3, 4, and 5. Is there, item sets that have a support equal or greater than the minimum support count? That is also my question here. That is also my question. Is there item sets that have a minimum, that have support that is greater or equal to the minimum support count? So someone is saying 2, 1, 2, and 5. So 1, 2, and 5, the support was 2. I think one of us said that. Okay. 1, 2, and 3. 1, 2, and 3, the support is 2. Okay. So the next move, let's see what we have in the next slide. And you realize that we have 1, 2, and 3, and 1, 2, and 5, each with a support of 2. Each with a support of 2. That's what we have. And so now the question here would be for us to ask ourselves, can we do another iteration? And that can be based on the maximum or the highest number of items that were bought for all the transaction IDs. And if you check the highest number of items that were bought for all the transaction IDs, the person who bought so many items was transaction ID 8, and he or she bought 4 items. So that is to mean even if you iterate again, you will not get item sets that are frequent, because the support will be just 1. The support will just be 1. And so there is no need for us to iterate again. So that is to mean item sets 1, 2, and 5, and 1, 2, and 3 are the most frequent items in this transactional database. Okay, let me try to pull this a bit. So what we are saying here, the most frequent items are item 1, 2, and 3, and item 1, yes, item 1, 2, and 3, and item 1, 2, and 5. Those are the most frequent items. Okay, those are the most frequent items. And so with this, we can compute the confidence level. And the confidence level, remember, if I take you back there, and I want you to help me compute the confidence level. I think so far now I have confidence that we understand what we are saying. Confidence of X leading to Y is given by the support of X union Y over the support of X. Okay? Confidence of X leading to Y is given by the support of X union Y over the support of X. So let's get back there and see what can we compute. So for example, we can say, what is the confidence? So we are saying for you to get the confidence, and remember, confidence is what is the probability that item set X is going to be bought together with item set Y. And for us to get that support, then we are saying if X leading to Y, that is if item set X being bought together with Y, the confidence is the union of item set X and Y over, the support of item set X and item set Y divided by the support of item set X. So that's what we are saying. So like in this case, if you look at it, if I ask you a question, what is the confidence that item set 1 and 2 will lead to 3? Just a quick one. What is the confidence level that item set 1 and 2 will lead to 3? So in that case, you need to check the support of item set 1 and 2 combined. Okay, the support of item 1 and 2 combined, and the support of item sets 1 and 2. The support of item sets 1, 2, and 3. Let me go back up there and we see what we have. So from our computations, you can see the support of 1 and 2 was 4. Okay, so if I was to say the confidence of 1 and 2 leading to Y, to 1 and 2 leading to 3 is going to be given by the support of 1, 2 union support of 3 over the support of 1 and 2. And so the support of 1 and 2 was actually 4. If you check from this particular candidate set that we have. So the candidate that we have in, I think this was candidate 2 or something, the support of 1 and 2 was 4. So we are saying, and the support of 3 from the first one, the support of 3 was 6. Okay. Okay, maybe we don't need the support of 3 because here the question is, yes, we don't need the support of 3. So we are saying we need the support of 1, 2, and 3, which we have gotten as 2 over the support of 1 and 2, which is 4. Okay. And so actually my answer is 0.5. Who got that? Oh yes, Stacy, you got it. 0.5. So if you multiply it times 100, then you'll get 50% as the confidence level. So our threshold was 60. Victor, I think you have a problem with the connection because I think people are hearing me. So what I'm saying is, and you're doing as I'm doing also. I'm just trying to. What I'm saying is that we are looking at 1, 2, and 3. So if I say 1, 2, union 3, it's the same as saying the split of 1, 2, and 3. Okay, Odira, I can see what you're saying. Please type in and let me know where I lost you so that I can be able to clarify in a minute. So when I say support of 1, 2, union 3, I mean it's still the same as saying support of 1, 2, and 3. And the support of 1, 2, and 3 we got as 2. But also the support of 1 and 2 we got as 4. So we are saying to get the confidence level that 1 and 2 will lead to 3, we get that by 1 and 2 union 3 over 1 and 2. So we get the support of 1 and 2 union 3, which we have already gotten as 2, over the support of 1 and 2, which is actually 4. And so the confidence will be 0.5. If you multiply times 100, then the percentage is 50%. And that is to mean the confidence we are getting here is lower than the threshold, the threshold of the confidence. That part of final computation of union. Okay. So look at this. So what we are saying is, let me get you back here. So we said for you to get the confidence, is mostly the question will be find the confidence level that particular item sets X will lead to Y, which in this case, what it means is the significance or the likelihood that a given item Y will be purchased when a given item X has been purchased. That is what we are saying. Now, for example, we can say the probability or the likelihood that onion and potatoes will be bought together with a bag. Okay? That is what we are saying when you talk about the confidence. And now I am expecting that we actually still remember these things. Oh my goodness. That we actually remember this, which we did in maths, sets. I think sets are in maths. They are taught a lot here in ZTech by one of my good friends. So union means all together. If you say intersection, then there are those that are overlapping. Yeah. So we may need also to differentiate what that means as well. So here we are saying it's union. So it's this and this. Okay, this and this. It's not this or this. Okay, it's this and this. And so, so in this case, what we are saying is we want to get the confidence level that 1 and 2 will lead to 3. And what does that mean? We are trying to get the confidence level, and look at what I had written here. That 1 and 2 leading to 3, okay, 1 and 2 leading to 3. The confidence is gotten by the support of 1, 2, and 3 divided by the support of 1 and 2, which is giving you 50%. Does that make sense to us? Maybe this may be helpful. What I'm having on the screen right now may be a bit helpful. Let me try to maybe make it a bit bigger. This may be helpful to us to understand. So I'm saying that the support of 1 and 2 leading, the confidence level of 1 and 2 leading to 3 will be given by the support of 1, 2, and 3 divided by the support of 1 and 2, okay? Which is the support of 1, 2, and 3 is 2, and the support of 1 and 2 is 4. And that gives us a half times 100, which gives us 50%. And so this is below the threshold that we expect. Below the threshold that we expect. So that would mean that those items are not frequent. They are not frequent because they have not attained the threshold. And if you do all the computations, you may actually realize there is no one of them that is attaining. But there are cases, of course, there are examples that we can do where the confidence level is getting to even 90% or 100. It's possible, depending on the combinations that you are looking for. But the most important thing is we want to generate the frequent item sets. And the moment we get the frequent item sets, then we are able easily to know that if I get item 1 and 2, there is highest level of probability that item 1 and 2 will be bought together with item 3, for example. Linda, you've not gotten how to. Okay. Odira, you've understood. Linda, you've not gotten how to get the support. Now, what I said is the support is basically the number of times a given item is appearing in the data set we are using. Let me repeat that again. Support is the number of times a given item is appearing, and this can be item or item sets. So a given item or item sets is or are appearing in a given data set that we are working with. And so like in this case, what we were looking at, if you look at this, how are we getting the supports? We were looking at this. This is our data set. Our data set was something like this. And so we were saying, so we looked at our items that are provided. So I'm explaining this to Linda. We looked at the items that were provided, which were item 1, 2, 3, 4, 5. The items that are available for all those that, there are only 5 items that were bought. It's only that they were bought by so many people. It's not just one person, by several people. But in actual sense, the items that were bought from the shopping mall were just 5. Okay? They were just 5. And so you get to a place where you want to count. So the support is basically how many times is item 1 appearing in the whole data set. how many times is item 2 appearing in the whole data set? How many times is item 3 appearing in the whole data set? So we said like item 1, we counted 1, 2, 3, 4, 5. Okay, did I leave 1? Yes, there are 6. 1, 2, 3, 4, 5. Okay, let me check again. 1, 2, 3, 4, 5, 6. Yes, there are 6. So the support of item 1 is 6. The support of item 1 is 6. Then I go to item 2, which is 1, 2, 3, 4, 5, 6, 7. So the support of item 2 is 7. Then second iteration will be combining 2 items together to check the support or the probability, not really the probability, but the number of times those 2 items were bought together. And we checked at item 1 and 2. It was there in transaction 1. It was there in transaction 4. It was there in transaction 8. It was there in transaction 9. And so the support count for item set 1 and 2 becomes 4. Okay. So when English doesn't work, then Eva is there to explain. I'm not very good in Kiswahili, so nikisema kujumuisha na kuhesabu na nini, I will mess you around. So that's what, but anyway, so I believe we are actually getting what we are saying here. It's basically just to try and look at the support. So the support is the number of times a particular item is appearing from a given, or either a particular item or particular, item sets. So they can be 2 items together, and we are scanning through the database or the data set we have and asking ourselves, how many times does that particular item sets, or does the item sets appear in the given, or rather in the given data set that we are working with? Who was asking this question? Linda, does that make sense to you? Linda, this is for you. Does that make sense to you? Oh, Linda is lost. Okay, let me hear from us on, we said that we can also be able to compute the lift. And we said the lift is it tries to signify the likelihood or the probability that a given item set Y is being purchased when item set X is purchased, while taking account of the popularity of item Y. Okay, so we are looking at 2 items. So let's say, for example, I want to hear from one of us here. What is the lift of 1, 2 leading to 3? What is the lift of 1, 2 leading to 3? So that would mean the support of 1, 2 union 3 divided by the support of 1, 2 multiplied by the support of 3. That is what it means. So what do you get? What do you get? What was the support of 3? The support of 3 was 6. So what are you getting there? Let me see if there are any answers. I'm waiting for the answer. What is the lift of 1, 2 leading to 3? What is the lift of 1, 2 leading to 3? Okay, let me repeat the lift concept. So the lift concept we are saying is given by this. The lift is given by the probability that X leading to Y, okay? The lift of X leading to Y is the probability of X union Y over the probability of X times Y. I mean, let me repeat that again. Okay, let me start from the beginning. What do we understand by lift? By lift, we are saying, what is the probability that given item set Y will be purchased when item set X has been purchased, considering the popularity of item set Y. For example, when new items come up, so there is a new brand of soap in the industry that we don't know. What is the probability that that particular new brand of soap will be bought when someone is buying, geisha that we know, or Cassons that we know? What is the probability? So that is what we are trying to look at when we are talking of lift. It is the probability that this item will be bought with this item, considering the popularity of this item. Okay, that's the lift. And so the computation is support of the first item union, item or item set. The first item or item set union, the second one, over the support of the first item or item set multiplied by the second item or item set that you have. And that gives you the lift. So who has an answer? Okay, Juma, correct. So it's actually 8.3% is the lift of 1, 2 leading to 3. Correct. You got it. Okay. So I think I would want to stop here. So if you understand the lift and the confidence as far as Apriori algorithm is concerned, then you're good. We'll talk about frequent growth algorithm from the next lecture and see just a few things to understand there. Then after that, we will dive into classification and clustering as the next topic. So let me just get you here. Now, if you look at this particular diagram, it was actually a bit of summary of what we have just done. Get the item sets. Let me get you there. So get the item sets, generate the candidates, and then from that, check the support and prune if the support is less than the minimum support count. Then you generate a new frequent item set, and then you come back here and you ask yourself if there is more items, frequent, more iterations to be done. If there is no iterations, then you stop. If there is, go back there, go round again, round again. So that's the iteration we've been doing, this iteration here. Just going round and round until there's no more iterations to be done. And so you stop and you are able to do the computations. Great, great. Now, there is a new rule that is coming up concerning ZDS, which we have been advised, and I want to be very, I want to be obedient to my boss. So this video will be available on our dashboard using a link. So, and all the videos that we have done before, I'll remove them from the big blue button and I'll attach them as a link, not the video itself, but just a link, which is, the video is going to be on YouTube, but you will have a link you'll have a link on the dashboard of this course, where if you click that link, then you can be able to view all that we have learned today. Okay. So what I'm saying is the videos, that the recordings of this class will be available on the dashboard, but they will not be available via the big blue button, but it's going to be just a link which is derived from a YouTube channel. And we are just trying to offload this system from a lot of content that is actually causing us trouble. So yes, that's what we expect. Any other question? Who has not spoken today? Kuna watu, they are very quiet. Caroline, I saw your email. Joseph, you're so quiet. Are you here? Clinton. Jamila, you have never been this quiet. Nelly, Nelly, you are very quiet. Who else? Who else? The kips are shining today, I'm telling you. Okay. Yes, the other lessons are also going to be available. And Joroge, the other lessons are also going to be available via a link on the dashboard of this course. Yes, we are done. So if you need to leave, you can leave. I will post a discussion forum, which you may need, of course, to, like as usual, to comment on. Yes. Okay, let me take the attendance even as you are exiting. I was just confirming some people here who have not spoken. Jamila, did you respond to my call? I called you and I have not seen you respond. Okay, okay. Kasure, okay, okay, I see you. Naftali, are you there? Yes, I see you typing. Okay then, so see you next time. See you next time. Thank you for your time. Thank you for your time.